So in this video, we're going to talk about how to solve and test, key part here, radical equations. All right. So when we have radical equations, we need to make sure you absolutely have to check your solutions. There are going to be problems that you're going to do where you're going to do every single step correctly, and you're going to get extraneous solutions. So let's put it in practice and see how to actually do this. So I'm going to zoom in on number 1 here. And basically what I want to think about is I want to think about isolating one of the roots. Now I'm looking at this problem, I only have one root, which is nice. So I'm going to isolate it, and I'm going to do that by subtracting 3 from both sides. Okay. So I've got the square root of x minus 2 is equal to, I think it's 9. It is 9. Now, everything in math has an opposite operation. The opposite operation to the square root is to square it. Now, what you do to one side, you've got to do to the other. So on the left side, the square and the square root cancel, leaving just x minus 2. The right side, you've got 9 squared, which is 81. Now, we're not quite done yet, but we're getting there. We're going to go ahead and add 2 to both sides. So x is equal to 83, and the common answer you're going to hear me say for this video is maybe. Maybe x equals 83. What you have to do now is to check your work. So what does that mean? That means in the original problem, everywhere I have an x, I'm going to replace it with 83, and I'm going to make sure that the left side and the right side match. So using your calculator, using whatever method you want, I want you to simplify this entire left side. Don't move anything from the left to the right. Just simplify what's on the left. So I've got the square root of 83 minus 2 plus 3 equals 12. So I have a statement that 12 equals 12. Yes, that is a true statement. So I now know that this is the solution to that radical equation. Okay? But you have to check your work. If you don't check your work, you are going to get extraneous solutions on some of these problems, and that's going to cause some grief. Okay, I'm going to slide over to number 2 here. My job is to get this root completely isolated. And so I want to peel away those extra things attached to it. So in this case, I'm going to add a plus 2, add 2 to both sides. So 4 times the cube root of x plus 1 is equal to 8. I'm going to divide both sides by 4. So the cube root of x plus 1 is equal to 2. Everything in math has an opposite operation. The opposite operation to cube root is the power of 3. Okay, so what you do to one side, do to the other. So x plus 1 is equal to 8, which means x is equal to 7, maybe. All right? By the end of this video, you'll probably be sick of me saying maybe. So off to the side here, I'm going to check my work. Every single time, you have to check your work. Okay? And when you do your check, what you want to do is just do the simple substitution. I replaced x with 7. Now, simplify this whole left side. And for anybody who's looking at the computer going, why did she put a 0 down? I have no idea. That's supposed to be equal to 6. I don't know. All right. So in my calculator, I'm going to put this whole mess, okay? So I've got 4 times the cube root. Let me get a cube root here. So let's cube root of 7 plus 1 is minus 2 here. So this whole thing simplifies down to 6. Does 6 equal 6? Yes, it does. So that tells me that this is my answer. Now, a common thing that students will sometimes do is, oh, if 6 equals 6, then 6 must be the answer. No. This is your check to make sure that this answer over here is the correct one. Okay? So the 6 equals 6, that's not your answer. That's just the check to make sure everything worked. Okay. On down to problem number 3 here. The kind of nice thing with problem number 3 is that the root is already isolated. The not so nice thing about problem number 3 is when we go to get rid of that root by squaring, we're going to have to square this x minus 2. So we've got x here equals x squared minus 4x plus 4. However you do your multiplication, do your multiplication. I'm going to subtract x from both sides. So x squared minus 5x plus 4. I'm going to factor this. So x minus 4, x minus 1. I'm going to solve it. X is equal to 4, x is equal to 1, and the answer is maybe. Maybe it is. I don't know. All right, so we're going to need to check both of our values, and you check them each separately. So the first one I'm going to do is the square root of 4. So 4, replace all the x's with 4s, okay? And separately simplify your left and simplify your right. So square root of 4 is 2. 4 minus 2 is 2. This is a true statement, so I now know x equals to 4 is true. That doesn't necessarily tell you anything about x equals 1. This could also work. It could not work. I will not know until I check my work. So let's see, square root of 1 is equal to 1 minus 2. Simplify the left side, simplify the right side. So square root of 1 is 1. 1 minus 2 is negative 1. Last time I checked, 1 is not equal to negative 1. So this is a false statement, which means that this answer is considered an extraneous solution, so we're going to eliminate it. You don't need to do anything else with it now that you know that it is not a possible solution. Okay, so number 4, let's see what we got here. A lot of negative signs. So let's see. I want to get this root isolated. So I'm going to go ahead and add 6 to both sides. So this is going to give me 1 is equal to the square root of negative 9 minus a. Because I now have the root isolated, I'm going to go ahead and square both sides. 1 squared is 1, so negative 9 minus a. Let's see what we got here. I'm going to go ahead and slide this a over and move the 1 over. So a is equal to negative 10. And again, hopefully the little voice in your head is already starting to say, well, maybe. We need to check it. So we've got negative 5 equals the square root of negative 9 minus negative 10. Be careful with all these negative signs, okay? Clearly negative 5 is negative 5, right? There's nothing to do there. But I want to put this whole mess into my calculator and have it simplify. Again, if you don't want to use your calculator and you just want to do it in your head, that's fine. Just be careful with the double negative here, okay? So this turns into negative 5. Negative 5 equals negative 5 is true, which means that this is absolutely the value I want for A. Okay? All right, we've got one more to cover, one more to talk about here, and it is the special treasure. You've got 2 roots. And unfortunately, you can't just square the left side and eliminate both roots. It's not how the squaring function works. So we want to isolate one of the 2 roots. I'm going to go ahead and take this root and move it to the right side. Okay, so I'm going to have the square root of 8n plus 1 equals 3 plus the square root of 2n minus 2. And now the fun begins. We're going to square both sides. Now, on the right side, I'm actually going to write this out. Okay? I believe it's going to help me keep track of everything, and I don't want to lose bits and pieces of this problem. So left side, the easy one, square and the square root cancel, so 8n plus 1. Right side, not so easy. You need to multiply this mess out. So we've got 3 times 3 is 9, plus 3 times root 2n minus 2, plus another 3 times root 2n minus 2 plus. Now, I have root 2n minus 2 times root 2n minus 2, which means I really have root 2n minus 2 squared. So all that turns into is just 2n minus 2. I want to do a whole bunch of cleaning here, all right, because this mess I want to simplify. So what I'm going to do is I'm going to look to combine some like terms. I don't know what just happened there, so hold on one second. So 8n plus 1, I'm going to combine some like terms on the right side. So I've got 9 minus 2, so that's going to be 7. I have this lonely 2n off to the side, so that's just going to say 2n. Now I have 3 times the square root and another 3 times the square root, and those roots are the same. So plus 6 times root 2n minus 2. Okay, we're getting there, I promise. All right, I'm going to subtract 7 and subtract 2n. So that's going to be 6n minus 6 equals square root of 6 times the square root of 2n minus 2. I'm going to divide both sides by 6. Okay, and I'm also running out of room here. Actually, yeah, I will go ahead and just continue on. When I post the key, it'll just pop up on the second page then. So this is going to be n minus 1 is equal to the square root of 2n minus 2. All of that work that we just completed eliminated one of the 2 square roots that we started with. Now, unfortunately, we have another square root to eliminate, so we're back in the position where now we want to square both sides. Okay? So, on the left side, I've got n squared minus 2n plus 1. On the right side, the square and the square root cancel, so 2n minus 2. All of the roots are now gone. Our job is to solve this. So I'm going to go ahead and subtract 2n and add 2 so that I can create a standard form quadratic equation that I can now factor. So n minus 3, that's a horrible 3. Let me try that again. There we go. And n minus 1, which gives me n equals 3, n equals 1, and the answer to both of those is a resounding maybe. Yeah, that part hasn't changed. So I'm going to take each of these values and check it in my calculator against the original problem. So let's say I want to check 3. So I've got the square root of 8 times 3 plus 1. I made that square root entirely too large. So let me try that again. Okay, let's do this. Minus the square root of 2 times 3 minus 2. And hopefully this left side is equal to the right side. So this entire left side I'm going to put in my calculator. Just as it's written, I'm not going to take, I'm just going to do it and be lazy about it and be okay with that. I suppose somebody once told me that it's not lazy, it's efficient. I don't care what it is, I'm going to make my calculator do the work. So this whole left side turns into 3. Yes, we know that 3 is equal to 3. So now that tells me that this is a good answer. That does not tell me anything about the other answer. It's entirely possible that you could do this problem and neither answer works. It happens sometimes. So you have to check all of your answers. Whether it's one answer, 2 answers, you've got to check them all. Okay? So 2 times 1 minus 2 is equal to 3. All right. So this whole mess on the left is going right into my calculator. And I am going to hopefully, it doesn't even matter if it works or not. You just have to check it to make sure it does. So this whole thing turns into 3. So yeah, we do actually have 2 solutions to this problem. So sometimes that happens. It's entirely possible you can do the next problem and you could get no answers, and then you just tell me no solution. So, lots of information on radical equations. Every radical has an opposite operation. It's a power. So your square root, the opposite operation is to raise it to a second power. Your cube root, opposite operation is the cube or raise it to the power of 3. As always with these videos, if you have any questions or concerns, send me a message. If you have any requests, send me those too. I hope this has helped.